questions 1 through 10 on the 2002 grade 10 AMC 10B. The ratio 2 to the 2001, 3 to the power of 2003 over 6 to 2002 is. So we most likely will have to do some factoring in order to get certain things that will cancel. So on the top, the 2 to the 2001 we will leave for now, but the 3 most likely will have to be factored, but I'm not sure entirely yet. But the 6 we can break up into 2 times 3 like that to the power of 2002. And therefore this now will be able to divide once we break it up into 2 to the 2002 and 3 to the 2002 like that. And then you can just split this. So the top we can do 3 to the power of 1 and 3 to the power of 2002 like that. And on the bottom, 2 to the power of 1 times 2 to the power of 2001, and this 3 to the power of 2002 we can just leave alone like that. And then now I hope you can see that this cancels with this and this cancels with that. So the only thing left is 3 over 2, and therefore that's the answer. So number 1, the answer is E. For the non-zero numbers a, b, c, define ABC is equal to ABC over A plus B plus C. Find 2, 4, 6. All right, so using the same operation that they gave us, it will be 2 times 4 times 6 all over 2 plus 4 plus 6 like that. So 2 times 4 times 6 is 8 times 6, which is 48, and 2 plus 4 plus 6 is 12. So 48 divided by 12 is 4. So number 2, the answer is C. The arithmetic mean of the 9 numbers in the set is a 9-digit number m, all of whose digits are distinct. The number m does not contain the digit. Okay, so we want to figure out the mean or the average of all these numbers here. So it looks like 9 plus 99 plus 999 plus 9999, so on. And then it keeps going like that. 5 nines. How many does it go up till? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 nines is the biggest one. So we got 5 nines, 6 nines, 7 nines, 8 nines, and then finally the last one is 9 nines. All right, so those are all the numbers. And of course, to figure out the average or the mean, you have to divide by the number 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. All right, so this is the big long. So the first thing, of course, I saw is that you factor out the 9. And if you do that, you'll get 1 plus 11 plus 1, 1, 1, and so on, like that. 5 ones, 6 ones, and you get the story. 7 ones, 8 ones, and finally 9 ones, right? And all over 9 like that. And then of course the 9s cancel, correct? So now you just have to add up all these numbers with 1s in them, and that's pretty straightforward. You can do it probably in your head or on a calculator. And if you do that, you'll get a sum of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? They're just adding up all of these guys. And they're asking you, the number m does not contain the digit. So this is the number m. Which digit is not in there? Well, we have every digit except which one? Except 0. So the answer to number 3 is A. What is the value of this expression when x is 4? So you can just plug in x equals 4. probably very easy to do that. Or you can simplify it. Let's see if I can simplify it. Either way, it's probably straightforward. I can factor out 3x minus 2, and if I do that, I'll get 4x plus 1 minus 4x, like that. And then there's a plus 1 at the end. And then 3x minus 2, the part in the square brackets just becomes 1, and then we have plus 1 like that. So now I can plug in x equals 4, a little bit less algebra for me. If x is 4, 3 times 4 is 12, minus 2, plus 1, like that. So this is 10 plus 1, which is 11. So number 4, the answer is D. Circles of radius 2 and 3 are externally tangent and are circumscribed by a third circle, as shown in the figure. Find the area of the shaded region. So we have a situation where you have two small circles that are tangent, right? So that means that if you drew a line all the way from one end to the other like that, they connect the diameters of both those circles, correct? I hope you are in agreement with me on that one. So I'll do it again. So if you draw a line from one end to the other, the diameters connect. And therefore, we have to label this. They've already labeled it, really. So I'll just write the other part. This is also 3, and that's 2. So the full distance from here all the way till here is 3 plus 3 plus 2 plus 2, which is 10. And 10 represents the diameter of the large circle. So I'll write DL, diameter of the large. So if that is the diameter, the radius of the large will be 5, correct? So this question wants the shaded area. So that would be pi r squared, large one, minus pi r medium, this guy right here, minus pi r small squared, this guy right here. And if you do that, you'll get the area of the shaded region, AS. So let's plug in the numbers. What is the radius of the large one? Well, it's 5, so that's 5 squared. What is the radius of the medium? It's 3, and the radius of the small is 2. Entirely based on what they've given me in the question. So this is 25 pi minus 9 pi minus 4 pi. So this looks like 25 minus 13, which is 12 pi, is the area of the shaded region, and therefore the answer for number 5 will be E. For how many positive integers is n squared minus 3n plus 2 a prime number? Okay, so n squared minus 3n plus 2. And they want this to be a prime number, so we have to figure out how many values of n will give us a prime number for this expression. We can factor it and kind of figure out how to proceed with this question. Is that a proper factors of that? I think so. And now let's just make a table. What is n, and then what is n minus 2 times n minus 1? All right? So n, what is the property? It's a positive integer. It's a positive integer. Okay, so let's start with 1. If n is 1, this becomes 0. So 0 is not a prime, right? So this is no good. If n is 2, this becomes 0 again. If n is 3, this becomes it becomes 1 times 2. 1 times 2, which is 2. Is 2 a prime? Yes, it is. 2 is a prime number. It's the smallest prime number. Let's keep going. When n is 4, we've got 2 times 3, which is 6. 6 is not a prime. When n is 5, we've got 3 times 4, which is 12. 12 is not a prime. And we can keep going forever. 4 times 5 and so on. 20, which is not a prime. Now what I want you to notice is that if you keep going like this, the numbers are always even. Why? Because you're multiplying two consecutive numbers. No matter what n is, they will be two consecutive numbers. So 5 and 6, 6 and 7, 7 and 8. And if they're two consecutive numbers, one of them will always be even. And therefore, if you take an even number and multiply it by an odd number, it will always be even, as you can clearly see from these examples. And therefore, since it's always going to be even, you're never going to get a prime number, because all prime numbers are odd, except one, and that is 2. 2 is the only prime number that is even. And that's a very important concept or topic or issue, and they make quite a few exam questions about that, based on the fact that 2 is the only even prime number. So in this case, the only value of n that gave us a prime number for this expression was n equal to 3. So that means there's only one possible n, and that means 6. The answer is B. Let n be a positive integer such that 1/2 plus 1/3 plus 1/7 plus 1 over n is an integer. Which of the following statements is not true? So 1/2 plus 1/3 plus 1 over 7 plus 1 over n. And when you add all these up, it becomes an integer. So let's get a common denominator, and let's see what we get. So the common denominator is going to be 2 times 3 times 7 times n. All right, so this first one becomes 3 times 7 times n. And the next one becomes 2 times 7 times n. The next one becomes 2 times 3 times n. And finally, we get 2 times 3 times 7, right? So this is 21n plus 14n plus 6n plus 42, all over 42n, like that. So the top becomes 41n plus 42 over 42n, okay? And if you split it up, it will become 41n over 42n plus 42 over 42n. And this becomes just 41 over 42, and this becomes just 1 over n. Now, how do I make this into an integer? By inspection, I hope you can see this becomes an integer when n is equal to 42. When n is 42, this will become 1 over 42, and if you add that to 41 over 42, you will get, I'll just write it out, 1 over 42. You will get 41 plus 1 is 42 over 42, which is equal to 1. So that expression becomes 1, which is obviously an integer, when n is 42. So n is 42. Now let's see. 2 divides n. N is 42. Does 2 divide n? Yes, it does. Does 3 divide n? Yes. 6? Yes. 7? Yes. N is greater than 84? Well, that is incorrect. That is not true. So of all these statements, E is the one that is not true. So 7, the answer is E. Suppose July of year n has 5 Mondays. Which of the following must occur 5 times in August of year n? Note both months have 31 days. So July of year n has 5 Mondays. Okay, so let's make a little calendar for ourselves, and let's see how this works. So July, this month, 5 Mondays. So let's just say the first of the month is a Monday. And therefore, the 8th will be a Monday. Just have to add 7, 15, 22, 29, like that. And then this is 30, and this is 31, like that. And then the month ends, and we get into August. And in August, the first of the month is a Thursday. And similarly, if you add 7, you'll have the 8th, the 15th, the 22nd, and the 29th will all be Thursdays. Correct? And you say, okay, well, is there any trick to this? I don't think so. I think that's it. The only other way or other alteration is if you shifted it and said, what if it started as the third of the month being a Monday. Well, in that case, same story, just add 7. So you get 10, 17, 24, and 31. And then this would become 1, 2, 3, and then same thing, 10, 17, 24, and 31. So again, 5 times you get a Thursday. So no matter which alteration you present, the day of the week that will occur 5 times in August is Thursday. So number 8, the answer is D. Using the letters A, M, O, S, U, we can form 120 5-letter words. If these words are arranged in alphabetical order, then the word USAMO occupies the position. For those of you that don't know, USAMO is the United States of America Mathematical Olympiad. So that is a competition you go to if you've done very well on competitions such as the AMC 10, AMC 12, and the AIME, American Invitational Math Exam. Okay, just a little aside there. All right, so if we have 5 letters, first of all, let's figure out how many possibilities. Well, they tell you already, 120. So what I want to do is show you a sort of a shortcut, and obviously you're not going to write out all 120 and then count which one is USAMO. Now, if you did put them in alphabetical order, you'd have first words that begin with A, then you'd have words that begin with M, then O, then S, and then U. How many words begin with A? Well, they're 5 digits or 5 letters, I guess. I'm so used to numbers. So if A is the first letter, we have 4 possible choices for the next letter, and then 3 for the next, and then 2 for the next, and then 1. So 4 times 3 times 2 is 24. So there's 24 words that begin with the letter A. And in a very similar or identical way, you'll get 24 words that begin with M, 24 that begin with O, and 24 that begin with S. So by the time in alphabetical order you get to the U's, you have already used up 96, right? 24 times 4, 96. And now, once you get to the 97th and onward, you'll have words that begin with U. All right? So here we go with our U words. Our U words, or the words that begin with U, there's 24 of them in a very similar way as all the other ones. And we want the second letter to be S, okay? So that means we first, remember they're in alphabetical order, so we have to first put in A, then we have to put in M, then we have to look at O, and then and only then do we get to S. All right? So remember, this is all 24. But we have to figure out how many begin with U and A. If U is the first letter and A is the second letter, the third letter we have 3 possible choices, either M or O or S. The fourth letter we have 2 choices, and then the last letter we have 1 choice. So this is 6. Okay? Very similarly, for the next one, UM, we have 3 choices, 2 choices, and 1 choice for those letters, and that's 6. And very similarly, 6 choices for those spots for a number or word beginning with UO. So now we've used up another 18. So we had 96 from these guys, and now we have an additional 18. So now we are up to 96 plus 18, 114. 114 is what we're up to. So we've already eliminated this. Now we get into the final 6. The final 6 words. And they all begin with US. like that, right? US. And in alphabetical order, they would be A, M, and O. And then we choose the second last letter, MO, OM. And then this is AO, OA, and finally AM and MA. Okay? So this is the 115th, 116th, 117, 118, 119, and finally the very last one, 120. So they're saying USAMO occupies which position? USAMO, it occupies the 115th position. So the answer to number 9 would be D. Suppose that A and B are non-zero real numbers and that the equation x squared plus ax plus b is equal to 0 has solutions A and B. Then the pair AB is. So x squared plus ax plus b has solutions A and B. So this is mathematically how you would write that out, right? I'm not factoring this. I'm just going by what they told me. Solutions. You understand what I mean by that? This information is what is here. This is just me copying that. Okay? But they're equal because the question tells you that they're equal, because these are the solutions. Now what I'm going to do is I'm going to multiply all this out here. Leave this part alone and multiply this out. So we got x squared minus xb minus ax plus ab, like that. And let's see, that gives me x squared, and we have plus minus b minus ax plus ab, correct? And that is equal to x squared plus ax plus b. So these coefficients will match. So that means that a over here is the same as minus b minus a, and this b right here is the same as that. The numerical value must be equal. All right? So let's deal with this guy here. If b is equal to ab, divide both sides by b, and you'll get 1 is equal to a. Great. We've got a just by doing that. Plug a equals 1 into this guy, and you'll get 1 is equal to minus b minus 1, and therefore b is equal to minus 2. And therefore our pair AB is 1, negative 2. So the answer to number 10 is 1, negative 2 is this guy, C.